like I say, to keep on going with this project. Again, here is the top, and like I say, here I'll take a pull on this, get a bucket to dump the stuff. Yeah, you can see how the wire mesh, some of the heavier stuff, has oxidized away, and it's just the plain stainless, so that got a lot bigger. So just the plain stainless wire was not too good an idea in there. As you can see, there's the oxide, and there's just the remnants of what's inside. So I didn't make a real good record of what I used in there, but you can see it's pretty well dyed there. It used to have a fairly substantial wire coming across there. It may be just stainless steel wire, and then the Inconel wire there. Yeah, it helped, but like I say, it needed better. I'm wondering, that looks pretty much like a chicken wire. Yeah, I figured that. Yeah, that's industrial. That's like a chicken wire I'd stuck across that front section. So that really oxidized away, and that didn't hold up that well, you know. But that was pretty low in the layer. So the stainless did hold up pretty good. This is, like I say, the chicken wire, and it's mainly burnt away to where you just have a minuscule amount of wire left in it to hold. So in a pinch that it might work, but that was an experiment. But the stainless wire held up pretty good comparatively. But, you know, the strength of it is not there anymore. So it's maybe 20 thousandths left. It probably was 32 when it started. So yeah, and it's pretty brittle stuff. So okay, tipped it up on 45. So I dumped some of this stuff down inside there, and I cut away the safety wire around the edge there. And now we can get it out. Yeah, you can still see the tape marks. I used duct tape over my form to seal it up, and you can still see the duct tape impressions in the castable refractory there. So this is, still in pretty good condition for that amount of time. Now cut that. That's down on the ground. So set this in my bucket, or just throw it in here for now. Okay, here's some cracking in the air tube. This was pretty thin stuff to start with, and I'm pretty pleased that it lasted this long. So this is the tube arrangement, where you have a crack going through there. As you can see, this has been pulled in. Like I say, before I used to have a tube from here coming into here, and as you can see, it was pulling the whole arrangement up. You got a similar crack on this side, but the tube itself is not that bad off. You get a chipping hammer or something similar. Okay. Metal really didn't burn away that much. For 27 years of running, it didn't really destroy the metal. I thought it'd be a lot worse. Say the main problem was having this tied to the piece that was getting hot. So what we need to do is, like I say, make a slip joint in this area. When I rework this, we'll make it a slip joint affair. So that's what we'll do. So this won't take too much to rework. This is that kiln shelf arrangement. Before, what I had done is, this used to come down to about here, and I had taken and drilled and perforated it to make for like a catalytic element of sorts, where it'd be preheating the smoke and everything that came through it, but it failed because it was a lot of defects when I drilled into it. So that is not what I'm going to do this next time. I'm going to go back to, I think, the center tube and have the support of the fire bricks below. That'll be a less expensive way of going.